Hello, everybody. Let's move on to the next chapter. In this chapter, we're gonna learn some new idea, the concepts about the object-oriented programming. The first section is about the basic concepts of objects and classes. Before we get into it, let's see the picture. Here's a picture show how we created a real software system using object-oriented technologies. In this picture, the left side of picture, we name it as programs domain. The right side, we name it as objects domain. Here are some symbols. The N stands for the element set in the program's domain, and the K, the relationship set in program's domain. The right side, the M, the elements set in objects domain, and J stands for relationship set in objects domain. What is meaning? Well, the left side, the program's domain means the real world. In the real world, we have a real system. For example, now we have a library. In a campus, we all know library. Inside the library, there are a lot of things. For example, we have a lot of elements. These elements, we use N to refer to these elements. For example, the reader. Here is the reader. For example, we have staffs. We have staff in a library, the librarians who manage the whole library. And I think there must be a book. The books in the library and the bookshelves. And we should have the index cards for us to search the book we wanted. So we have a lot of elements. Use N, use a symbol to stand for them. Here we have a set, an element set for all its elements. And we must notice they have a relationship between them. For example, I'm a reader. Here are the books. A reader should borrow books from the library and return books. So between the reader and the books, there's a relationship. They borrow and return. And suppose I'm a librarian. I manage the whole library. So I manage all the books. I can put the books in one of the bookshelves. And I can manage the index cards and manage the readers. We announce one of the readers entered the library or refused her or him to enter the library's ballot box. So it's the relationship. We use key to stand for all of this relationship. We get a set. So K stands for the relationship set and N stands for the element set. They are all in the real world and a real library. Well, now suppose we want to build a digital library or a online library. So we get to the right side, the object domain. Before we build a digital or online library, so this is the software. The left side is a real library. right side is, suppose we want to build a line online library. Okay, the right side. How to build them? From the real library to the online library. So we must think about these elements and their relationships, how to map them to the right side. For example, the book. The book is element. In the online library, we must have the book. So we must have book here. But the real book in the real library has many features. For example, the covers, the contents, and the price, and the author. A lot of features. But in the online library, we must cut some features. We only use some of the important features for our software. That means we don't want these features, for example, this price. The price to a library, the price is not an important feature, but if we want to build an online bookstore, the price is an important feature. So this step, we should make some abstraction to remove unnecessary features inside the step. This is very important. From the problems domain to the objects domain, you must map some of the elements to the objects in the object domain. The real world, the real element, and the objects. From the real elements to the objects. You do it, you must think about them. Think about all the features and only keep these features that are important for software and remove those features unnecessary. Yeah, that's the idea. And the relationship between these objects inside our online library, they have a relationship. For example, we have a reader. The reader in the book will borrow and return. This relationship is still existed in our software, in our online library. So it's important. But we must have some kind of method to describe this relationship. Okay. Here we get this object domains, which M stands for the element set in object domain J. We describe the relationship set in our object domain. So this very important mapping from the real world to the object world. This is how it works. If you want to build a real software based on the real problems, well, for example, we want to build an online library based on real library, we should do following steps: mapping all the elements to the objects, mapping all the relationships between these real elements to the relationship between these objects. So this is very important. And next, how to build them. What is an object? An object is software bundle. It's a software bundle means you must use resource. The source of the computer system, for example, memory. In the future, we will show you how to create objects. When you create objects in a statement, we'll use the memory. We get the space inside the memory and put the object inside. So the object is the software bundle. Inside the software bundle, we have the two stuffs. The first is variables. The second one is methods. So inside the object, we have variables, we have methods. Okay, let's see. We have a bicycle, a real-world bicycle. Now we want to build a digital bicycle and a software. That means we will create a bicycle object. How to do it? I have told you before. We must make some abstraction. We must remove the features unnecessary and only keep the features that we want used in the objects. For example, the bicycle. The bicycle has this brand because its products, has its price, has a corner, or other kind of things. But to our system, for example, our software is used for describe a race, a bicycle race. So inside this software, all these other features are not important. We should keep the features that a bicycle need when it's moving. So these features include the speed of the bicycle. Yeah, the speed of the bicycle. And around the speed, we should, if you want to move a bicycle forward, we have pedals. In a bicycle, you pedal the bicycle forward and make the pedal rotate and the bicycle forward. So we have a pedal. So the pedal, the speed, the pedal how it rotate. We have the RPM per minute rotate. The second feature. The third feature is a gear. Because we want to get more power from the pedals, we use gears and choose a suitable gear will make us get the suitable speed balance. So we have the third features is a gear. So we have three features: the speed of the bicycle, the rotate speed of the bicycle's pedals rotating, and the gears. So this is feature. This is the variable. This is the data. And how to make this change? We should have method. To change the gear, we have the method named change gears. To change the speed, for example, we have the method named brake. Once we brake it, the speed of bicycle will get down to zero and start. And with the change cadence method, and use this method, we change the speed of rotation of these pedals. So we have change cadence. So as three methods: change gears, brake, and change cadence, and three variables: speed, RPM, and the gears. For the bicycle, we should have these stuffs inside of this up to inside this software bundle. Okay. Well, so we have two concepts. One is instance variables. The instance variables is this data. For example, the speed of the bicycle, the pedal cadence of the bicycle, the gears of the bicycle. They are instance variables. The instance variables are owned by the objects itself. So if I have two bicycles or three bicycles, each bicycle have these variables, but the data, the value inside this variable, it's very important because the instance variable is owned by the object itself. And next is instance method. How to change the values variables? You cannot directly change them. It's not allowed. It must change with methods, with this instance method. For example, if you want to change the speed, use brake method. If you want to change The parallel cadence, use change cadence method. If you change gears, use change gears method. These methods will change this data, this variable inside the variable safety. So we have instance variables with instance method. That's idea for them. Well, next is idea, name it encapsulation. What is about encapsulation? Encapsulation means, well, now we have the software bundle, all this data, the data we stands for the values or the variables. We have the method. This method means how to operate this data up to this value inside these variables. So these things, the two stuff, the method and the values and variables have been put inside the black box. In fact, it's black box. We don't know how it's implemented unless we are the designer of the object. To the designer of the bicycle, we do know how to implement this, how to implement brake, how to implement gears, how to design it. We know, we write code for them. But as a rider, to use a bicycle, you don't need to know it. You only need to know how to operate it. That's enough. So as a rider, use by a brake method to make this bicycle stop. Use change gears method to get the gear you wanted. That's enough. So to a rider, the bicycle is a black box. It's a very important idea for us. It means encapsulation. So inside this black box inside the bicycle, these methods can be changed. If the designer want to change them, they can write this code. At the rider, it's the same because we use a brake method to optimize this bicycle, make it stop. Maybe in the future, there's new technologies comes out, and the designer wants to apply this technologies to the bicycle and use a new uh, some kind of mechanic theories, mechanic items to change this brake, changes brake, make it more efficiency, yeah, more powerful. To change the code, it's okay. We don't care. To a rider, it's the same. We use the brake. We make this bike stop. That's what I want to do. It's encapsulation. It's a very important idea for us. And the next idea is modularity and information hiding. The encapsulation means we can make the information hiding. Which information? How to implement this method, how to implement the brake method, how to implement the change cadence method, how to implement this change gear method. This information are hiding. We don't know as a rider. So it makes the software safety. And at the same time, the capsulation make a real model, make the bicycle as a real object. So it means this modularity, it's very important, modularity. So now we have a bicycle. So we have two bicycles. We have another bicycles, I put them into a race. For example, we design a game, a race game at the software, and want to use it, all these bicycles and all these bicycles objects. They are model. We put them together. We build a game program. Okay, that's it here. This is all about objects. The next, what is a class? So, as we know, the objects are bundles. But how to get them? We should run code. Run code and create objects and put the object into memory of a computer system. So we should have a blueprint, or we name as prototype. That is idea of a class. So a class is a prototype that inside the class is the same as the objects. We have the variables definition, we have the definition for these methods, and actually the class is a code. We write this code, and in the future we're talking about how this code is written. The structure for the class, we have this class, we write this code for class, and once we get a class code, and then we have statements, we have a new keyword. I use this keyword to create objects. Okay, in the future, we'll give you more detailed process to do these tasks, to build object-based classes. So this idea about the class is a blueprint, it's a code, it's a code frame, it's a prototype. Use this class, use this code, we can create objects. And one important point is we have one class, and based on this class code, we create more than one object. They have the same type, but they're totally different. For example, I have a bicycle class, and we use this class, and we build one bicycle object, or two, or three, or lots of bicycles that you want, but all these bicycles own their own variables. The variables, the value inside the variables may be different. That's the point. So now I have two bicycles based on the bicycle class. The two objects. Yes, one is my bike, another one's your bike. So we notice that is values are totally different. For example, speed. The speed of my bike, the current speed, is 10 miles per hour, and your bike, the current speed is 15 miles per hour. And the cadence, my bike's cadence is 60 RPM, and your bike only it's 90. My bike cadence is 60, and your bike is 90. It's different. And the gear, current gears, my bike, I use the gears the fifth gear, but you use the second gear. Okay, this is totally different. So each instance, or we name the object, has its own copy of the instance variables. This is important. This is instance variable means. It depends on the object itself. So different objects, the value inside these instance variables may be different. Okay, that's the idea. And now we have a new concept named as class variable. And class variable is different from this instance variable because the class variable cannot owned by any of these objects. It's shared by among these objects. Yeah, that means the class variable is owned by all these objects. For example, I have the variables, a class variables named as number of gears. This is the class variable. The number of gears we give its value as 18. Now we're 18. The number of gears 18, and your bike and my bike and his bike or her bike, all the different bike object, but the class variable is shared among this object. They are all the same value as 18. So it's important. So class variable, if you want to share something among the different objects, you should use class variable to define its value, to define its variables. So Uh, Class variable, another name we call it a static field. In the future, the static field, we're talking about something about how to initialize it. But here, you must remember that a class variable is shared among these objects. It's different from this instance variable. The instance variable is owned by one of these objects, but the class variable is shared among all these objects. Okay? So to sum it up, the objects provide us the benefit of modularity and information hiding. There's two important benefits. One is modularity, another one is information hiding. And class is a code frame. It's a blueprint. It provides us the benefit of reusable factory. What is a reusable factory? We have code. We define a class bicycle, and basis class we use the statements to create objects. We build one or two or three or lots of objects. The type is the same, but it's totally different objects, lots of objects based on this one class blueprint. So it means when you reuse this code, define this class. So it limits reusable factory. This is the second concept we have named. And the third concept is the message. Okay, what is the message? If you know, if you want to build a software system, one object is not enough. Maybe have two or three or more objects inside our system. So our system is composed of a lot of objects. And this object, the collaborator, they work together and do some tasks and do something we have designed. So how these different objects interact with each other, communicate with each other, they use messages. These messages do the job. They work as a team. So it's important. And how the message, the actual messages means it's composed of three components. The three components is the first is the object. It's the destination object which is message is stressed. For example, now we have two objects in the system. It is your bike. Its type is a bicycle. Its object, and here it's a rider. For example, you. You is the rider, and you ride the bicycle. So your bicycle, this object, is the message will be sent to. And you send a message to your bike how she should do. Yeah. This bicycle, for example, you are changing gear, so send this bicycle. This method named as change gears. So change gear is the method to perform by your bicycle. You send a message to your bicycle to do what? To change gears. And which gear you want? As the parameters, you get this value. Yes, a newer gear, for example, well, we have the fifth gear, and we change to second gear, so we get a different gear as the parameters, as a message. So it is the idea of the messages. In fact, this is we have maybe we have this the similar function in other language. The may limit as function invocation. It's the same actually. The message sending, the message receiving, message operation is the same as the function invocation. It's the same idea, but it's a little different between them. That means, well, the message sending from one object to another, the two objects, they may located in the same computer, the same machine, but in general, in today's world, they may located on different machine, and the different machines are connected with each other by internet. So this idea that means these objects send messages between them and make some kind of operations, and these objects on different machine. In today's real software, it's very common. For example, you have phone, you have smartphone. I use smartphone here. You install an app on it. For example, the app is for the online shopping. Yeah, for example, online shopping. You add app on your phone. Its function is you can use it, go online and buy something, an online shop. And how it works, it's only app in the phone. Suppose this is object, and if you want to work, you must have the map service. You should know where you are, and around you, for example, the reader is 2 kilometers. The shops around you, so you must use a map. For the map service, the map is not inside your phone, so you want to use map service, you must interact with another object. Its name is map object. The map object, this map object is not on your phone, it's on the server. And your phone and your server and all these things, they are connected with each other through the internet. So you access map service, you send a message to the map service, to the map object, and get your location. You send your GPS parameters to it, and it gets your GPS, and you know where you are, and it send back to your location and the shops around you. This is map object. And now you know where you are and want to buy something. If you want to choose the items and put in the shopping cart, and the final step is to pay a bill. So another object you should use. The object is bank, the pay service. So another object you must send messages to the bank while the money won't pay. So the bank, you have account in bank, the bank will make some operation to a balance and return your result. Well, your success or your failure or something else. So these objects, they are not on the same machine. They are on different machine, different computer, and all these computer connect with each other through the internet. This is the idea of the messages. We use messages, we connect all these objects together, and we communicate with each other, and we use this to build our system.